Today we're going to look at probability of mutually exclusive and mutually inclusive events. Two or more events that cannot occur at the same time are called mutually exclusive events. Normally you will see that the question has an "or" in it, and the formula is that you find each probability and add the amounts together. So examples of mutually exclusive events that cannot happen at the same time would be like rolling a die, getting a 3 or a 4 on the face of a die. That cannot happen on one roll. Or getting an odd or even value on a die, because those are opposites. They cannot occur on a roll at the same time. Drawing a card out of a deck of cards, getting a 2 or a 5. Those are two separate events. They cannot occur at the same time. Or getting two different suits like heart or diamond, because you either have to have one suit or the other on one card. Here is a Venn diagram to illustrate the two events. So one circle represents all your cards that have hearts. The second circle, or the second event, are all your diamonds. And since there is no card that has both heart and diamonds, these two circles do not overlap. They're two separate or exclusive events. Inclusive events mean that they can happen separately, but they can also happen at the same time. So that might be rolling a die, getting a 2 or an even value. Notice that 2 is an even number, so these two events can happen at the same time. Drawing a card, getting a king or hearts, you can have them as separate events, but you know you also have a card that has both king and heart on it, so it can happen at the same time. Same thing with face card or a queen. Queens are face cards, so those two events can happen at the same time. Notice the formula is a little bit different. You still have your two separate probabilities, one for the face card, let's say, one for the queen, but then you're also going to subtract out the number of cards in this case that are both queen and face cards. So we'll do some examples of that in a minute. So here's a Venn diagram again, going back to the example with cards and getting 5 in spades. So you have your circle represents all your 5s and the B circle represents all your spades. And there is one card that is a 5 in spade. That's the card being shared in both groups. So when you're setting up your probability or calculating your probability, you're going to set up a ratio for all your 5s. That's the entire circle here, including the 5 of spades. You're setting up a ratio for your B event, which are all your spades. So once you set up these two ratios, you've actually counted this amount here twice, in this group and this group. So that's why we have to subtract one of those amounts, or the number that's this probability value here, 5 in spades. We have to subtract it out because it's been factored in twice in the formula. So basically this value here is going to cancel out one of these. It doesn't really matter which one, but it's going to cancel out one of those amounts so that you're not double counting that value in the formula. So we'll practice identifying exclusive or inclusive events and then calculate the probability. Here we are rolling a die, getting a 2 or 3 on a die. So these two events cannot happen at the same time. They are mutually exclusive events. You would set up two adding fractions, one that represents getting a 2, the other one represents getting a 3 on a die. So out of 6 options for both, you have one value that's a 2 and you have one value that's a 3. Remember, we're adding fractions now, so your denominators need to be common or the same, and your numerators add, and then you reduce your ratio. Drawing a card, getting a face card or a red card. So can these two events happen at the same time? Is there such a card that is got both a face on it and red? And the answer is yes. So this is a mutually inclusive situation, which means we have our two adding fractions and then a subtracting fraction. We have a ratio that represents all your face cards. Second one is all your red cards, and then you're going to subtract out your face and red cards. Okay, so we start with a total of 52, really for each of these ratios. There's 52 cards in the deck. We have the number of face cards is again 3 times 4, so 12. Red cards is half of the deck, so it's 26. And then how many face cards are red? So remember the cards are either black or red, so the 12 here is the total. That means half of those are red cards. And we've counted those red cards here in the 12, and we've counted all the red cards here, it's 26. So the same cards have been counted in both groups. That's why we're going to subtract one of those out, which are your 6 red cards. So then 12 plus 26 minus 6 gives us a total of 32 out of 52, and then you're left with reducing your ratio. Probability of drawing a card getting an ace or a queen. So we have to think, is there a card that has ace and queen on the card at the same time? And the answer is no. This is a mutually exclusive event. These occur separately and cannot occur at the same time. So we have two adding ratios. One that represents all your aces and the other one represents all your queens. And so out of 52 cards each, we have a total of 4 aces, 4 queens, and then we add up the numerators and reduce. Drawing a card again, getting a king or a heart. Can this occur at the same time? The answer is yes. Mutually inclusive events, because we do have one card that is a king of hearts. So we have all our kings, all our hearts, and then the king of hearts. So we have a total of 52, 52, 52, 4 total kings, 13 hearts, and 1 king of hearts. The probability is 4 out of 13. What are the chances of rolling on a die an odd number or 2? These events cannot occur at the same time, so they are exclusive events. And we have 2 ratios that add. One that represents all your odd values and one getting a 2 on the die. So out of 6 possibilities, 3 values are odd. Out of 6 possibilities, 1 value is a 2. So 4 out of 6, or 2/3 chance for getting an odd or a 2 on a die.